Hello guys, welcome to all of you. Let us see a question asked in GATE 2024. In this question, it is said that as shown in the circuit, the initial voltage across the capacitor is 10 volt. The initial voltage, that is V0 minus, is given as 10 volt with the switch being open. When the switch is open before t is equal to 0 second, the switch is then closed at t is equal to 0 second. Now switch is closed at t is equal to 0 second. The total energy dissipated in idle zener diode Vz is equal to 5 volt after the switch is closed in millijoule rounded up to the 3 decimal. So total energy dissipated in this zener diode has been asked when switch is closed at t is equal to 0 second. Here breakdown voltage Vz is given as 5 volt. So let us see how can we solve it. Before solving this problem, let us understand how a zener diode acts in a circuit when it is connected to it. Suppose this is the zener diode and voltage across it is Vxy is applied. Here Vz is the breakdown voltage of zener diode. So first case, it may be that in the question it is said that zener diode is idle. If zener diode is idle and Vxy, which voltage is applied across this zener diode, is less than breakdown voltage of zener diode, that is Vz, then this zener diode will act as open circuit. If voltage applied across zener diode is greater than breakdown voltage or equal to the breakdown voltage of this zener diode, then it will act as a constant voltage source, and the value of constant voltage source will be equal to Vz, that is the breakdown voltage of zener diode. The second case may be that zener diode has some internal resistance Rz. If Vxy voltage, which is the applied voltage across this zener diode, is less than breakdown voltage of zener diode, then this zener diode will act as open circuit. If applied voltage is greater than breakdown voltage of zener diode, then it will act as voltage source with its internal resistance Rz. So this circuit can be used instead of this circuit for simplification of our problem. Now in the given circuit, we can see after t is equal to 0 second, this switch will be closed. So we have closed this switch here, and this current IT is assumed to be flow in this circuit when this switch is closed. As we can see that here 10 volt source is connected, as this is the initial voltage of capacitor. So after t is equal to 0 second, it will be act as a voltage source for this circuit. Here 10k resistance is connected and Vz voltage, that is given as 5 volt in the question. Now we have to understand for how much time this current will flow in the circuit. As we can see that here is the voltage source, and this voltage source will provide supply to this resistance and this zener diode. The current in the circuit will flow up to which the voltage is greater than or equal to this 5 volt across this zener diode. As we have seen in our circuit that if voltage applied across zener diode is greater than breakdown voltage of zener diode, then this will act as a constant voltage source, and the voltage of this constant voltage source will be equal to breakdown voltage, that is given here 5 volt. So it will be equal to 5 volt. We know that some energy will be dissipated by using this 10k ohm resistance, and some energy will be dissipated by using this zener diode. This voltage will decrease as the time will passes, and voltage across this capacitor will reduce. When the voltage across this capacitor will be equal to 5 volt, then this zener diode voltage will be 5 volt also. So the current flowing across this resistance will be equal to 0. So no current will flow in this circuit when the voltage across this capacitor will become 5 volt. Energy dissipated by any element can be calculated by multiplication of voltage into current, and if we integrate it for a time t up to which the current is flowing in the circuit, then total dissipation can be calculated. So here we will calculate this IZT current up to which flowing through this zener diode, and we will multiply it the voltage across this zener diode, and we will integrate it from 0 to t second, since this switch is closed at t is equal to 0 second, and we will assume that up to t1 second or up to t second this current is flowing in the circuit, after which this voltage across this capacitor will become 5 volt, and the current in this circuit will become 0, and no dissipation further will occur across this zener diode. So first of all, we will calculate current in this circuit. As we can see that the voltage is decreasing with time, due to which this current value also decrease with time. So we need to use the transient for calculation of the IT current. As here we can see for t greater than 0 second, the voltage across this capacitor will also be 10 volt, as the capacitor cannot change its voltage instantaneously. So V0 plus will be equal to Vc0 minus, that is 10 volt. Now we can apply this formula for calculation of the voltage across capacitor as Vct equal to Vc infinity plus Vc0 plus minus Vc0 infinity into e to the power minus t by tau, as we have seen for the calculation of transient. Here Vct will be equal to, as at infinity the total voltage across this capacitor will be 0. Since its value is decreasing, so we will assume that voltage across t is equal to infinity time, it will be equal to 0, plus Vc0 plus its voltage is 10 volt minus Vc infinity is 0 into e to the power minus t by tau value is RC, since it is a RC circuit. VCT will be equal to 10 into e to the power minus t by RC. Assume it equation number 1. As we know that zener diode will remain on up to voltage across it is greater than equal to 5 volt. So IT will flow until voltage across zener diode is less than 5 volt. If voltage across it is 5 volt, this IT value will be 0. So we have to find out the value T up to which the current IT will flow. For that, we will use that this VCT voltage will become 5 volt. At that time, the current in this circuit will be 0. So we will find out that value of time. If VCT is greater than equal to 5 volt, then this zener diode will be on. Now we will put VCT is equal to 5 volt in this equation number 1. Then we can find out this T1 time equal to 0.0693 second. So we can say that up to 0.0693 second, this IT current will flow in this circuit, and due to flow of this current, this zener diode will dissipate energy. So we can use this T value in the integration as 0.0693 second. As we have calculated T1 is equal to 0.0693 second, so for up to 0 to T1 period, this zener diode will be on and the energy will be dissipated across it. So we have put 0 to T1 Vz into IT dt. Now we have to calculate the value of IT. We can use IT formula as we usually use in transient equation, that is IT equal to I infinity plus I0 plus minus I infinity into e to the power minus t by tau. At infinity time, the current across this circuit will be equal to 0 plus I0 plus value will be equal to, we can see from this circuit, I0 plus value will be equal to Vc0 plus minus Vz upon 10k. So we will put it in equation. So here we can put Vc0 plus minus Vz upon 10k minus I infinity value 0, e to the power minus t by tau value is Rc. Now we will solve it and we can find out IT value is equal to 1 by 2 e to the power minus t by Rc milliampere. Here Rc value is 0.1 second. Since resistance value is 10k and capacitance value is 10 microfarad. For the calculation of energy dissipation, we can use this formula E equal to 0 to T1 Vz IT into dt. Now put the values equal to 0 to T1 value is 0.0693 second into Vz value is 5. IT value we have calculated here, we put it here into dt. Now if we solve by putting Rc is equal to 0.1 second here, we can find out the energy dissipated across this zener diode is equal to 0.125 millijoule. It is the one of the good question asked in GATE 2024, which is the combination of zener diode and RC circuit. I hope you will have understand the concept how can we solve the circuit when a zener diode is connected in a transient circuit. See you guys in next videos.